sorry. So the difference between recursive and closed is like a function. You can plug a number in and get an answer. Recursive means that it relies on the term that comes before it. So if you need the 100th term, you have to generate all 99 terms that come before it. So it's kind of annoying to find the large terms. When you read a recursive formula, see how these little n's are subscripts? You're not plugging in things for n. When you look back on the previous page, n is like a bigger number in a formula. That's when you plug things in for n. In recursive formulas, you don't. So in a recursive formula, wherever you're at is considered a sub n or a sub k, whatever they're going to call it. And then the next term is just called n plus 1 or n plus 2. So these are in front of your term. And then behind your term in order are n minus 1, n minus 2. So this is just relative order in a sequence. So if you're at n plus 1, you know n comes before it. But if you're at a sub n, you know that n minus 1 comes before it. So if you're looking at example 1, given the recursive formula, find the first 5 terms. So this says, hey, to get the term you want, a sub n, what you need to do is look at the term that comes directly before it, because that's a sub n minus 1, and just subtract 10. So they're giving you that the first term is 29. So to get the second term, you take the term before it and just subtract 10. So the next term would be 19. And they want you to generate the first 5 terms using that pattern. So just subtract 10, 9, subtract 10, negative 1, subtract 10, negative 11. Does that kind of make sense? So it's like reading a story as opposed to plugging numbers into a formula. All right, so number 2. They've used kind of that same language. To find the term you want, take the term before it and add 30 this time. So you're starting at negative 28, so you're just going to add 30 each of those 4 times. So the pattern itself is not hard. Reading the formula, I think, is what is challenging. And you have to generate all the terms in order. You can't just skip. So if I add 30, I get 2, and then 32, and then 62, and then 92. Does that sound right? So adding 30 each time. So it would be better if we had a closed formula, because then I could just plug in 5 and generate 92. I can't plug in 5 up here and generate anything, right? All right, so on 3 and 4, they want you to write a recursive formula. Find the common difference and then write the recursive formula. So I'll do 3 and then you try 4. So A, you can write a sub k or a sub n. A lot of times with recursive, it's written as a sub k equals a sub k minus 1. What am I doing to it each time? So to find the term I want, take the term before it and do what? Add 3 or subtract 1? What am I doing each time? Yep, subtract 7. And with a recursive sequence, you have to define the first term. So the first term for this sequence is negative 40. So this basically says start at negative 40 and subtract 7 every time. So I'd like you to try example 4 for a minute, writing it in that same kind of formula recursively. And I want you to recognize that recursive is not super helpful. All right, so we got a sub k equals a sub k minus 1 minus 4, where a sub 1 equals 17. I just want to show you one other way I could have written this sequence. I could have written this as a sub k plus 1 equals a sub k minus 4. So if I jump to k plus 1, k is the term that comes before it. If I'm at k minus 1 is the term that comes before it. These mean the same thing. So when people write a recursive sequence, you're just reading a story, they might have a preference of, you know, to get the next term, you write it this way, or to get the next term, you write it this way. Both of them mean the next term. And I'll have to talk about the Fibonacci sequence next time, because that's a good one. I have a little video about that. And it does appear in science a lot. Given the first term and the common difference, find the recursive formula. So you could do that on your own. And then given the explicit formula, find the recursive formula. Why don't you practice 5 and 6 for a minute? Because 5 and 6 are the same as 3 and 4, where you have to write the formula yourself. I think writing it a few times helps you remember it, and then we'll get back together at 7 in just a minute. All right, so I'm just going to let my video record the answers to 5 and 6. Then we're going to try 7 and 8. All right, so in 7 and 8, it says, given the explicit formula, that just means closed. Closed just means you can put in n and generate the terms. Find the recursive formula. I can't find a recursive formula unless I can look at the first few terms, because I can't tell from this like what exactly the starting value is or what the common difference is. Maybe you can. But another way you could start is just by generating the first 3 terms using the closed formula, and then you could generate the recursive formula from there. So if I plug in 1, 1 minus 1 is 0, right? So I'm starting with just the number negative 20. Then when I plug in 2, 2 minus 1 is 1. So I'm taking negative 20 and I'm subtracting 7. So I'd be at negative 27. Then when I plug in 3 for term 3, this becomes 2. So this becomes negative 14. So I'm taking negative 20 and subtracting 14. So then I would be at negative 34. So maybe it's easier to see it. Okay, my starting term is negative 20. They just kind of wrote this funny. The negative 7 they wrote over here. Usually I put the negative 7 in front of the n minus 1. So to write that recursively, a sub k equals a sub k minus 1. What are we doing? We're subtracting 7 each time. And we're starting at term 1 as negative 20. So I think you could do number 8 now, because number 8, this negative 6 really should be structured in front of the n minus 1. So if you know the starting term is 36 and the difference is negative 6, go ahead and write number 8 right now, and then maybe I'll do 9 and you can do 10. So do number 8. I'm going to write the answer up in just a second. So hopefully it's getting just a little bit more familiar of how to write a recursive sequence like a story instead of worrying about what you're plugging in. I guess number 9 is the one that I should have been talking about, that it's hard for you to see what the first term is here. This one I guess I should have recognized, but this one's not written in the form that we're used to. So what I would do is generate your first 3 terms to make sure you know what the sequence is. So when I plug in term 1, 2 times 1 is 2. So right off the bat, I'm taking 26 and I'm actually subtracting 2 from it. So my first term is actually 24, which I couldn't read from this original sequence. Then when I plug in 2 for the second term, I take 26 and I subtract 4. So I'd be at 22. Then I'm going to take 26 and subtract 2 times 3 for the third term. So 26 minus 6 would just be 20. So I think now it's easier to see that our starting term was 24. So I can say, how do you get the term you want? Take the term before it, and I'm subtracting 2 each time. So if you could take another minute and wrap up number 10, and I'll put the answer up here.